Okay, it's time to answer the questions about mismatched solar panels. Okay, so I'm going to run this thing on this gadget here. Now, this panel right here is the panel I've made. If you didn't actually see it, I'll put a picture up and a link to the video in which I built this. Okay, let's get the whole thing in there. So let's plug that in. Okay, hold on. I'm working with one hand. Okay. So let's plug this in. Okay, that's plugged in, and you can see the faint light of the LED lights, which we know works on 5 volts. Okay, that's going. Okay, so now what we want to see is we have this adapter, which we're going to plug into our EcoFlow. That's our EcoFlow. Okay, so, and that should light up. Let's see. And there we have it. It lights up. Okay, so we're going to bring the cord around because that is the positive and negative. Okay. Now, I'll show you the diagram later, but this, my friend, is the circuit you've been waiting for. Okay? This takes mismatched panels, and you'll be able to hook them on, which we're about to do, and then I'll let you hear that this circuit actually works. Okay? So, let's see if we can get it up on something so we can actually see what we're doing. Okay, now what we're going to do, because we want to get this power pack out of the way, we want to get that into the frame. Okay, sorry about the mishap, but we had to solder this circuit into place. Let's give it a good look at this circuit here and put a little light on there, and we can see that I soldered it. Okay, so that's a good way to see the circuit. And let's put this back on the stand here and actually look at the diagram, the meter I mean, and see if we get 18 volts or close to it. Now, we have 1766. That is what we're supposed to. This particular solar cell is only putting out 17, but it means that the 5 amps is not pulling down. So let's see if we can get a reading. Let's turn that off and see if we can get an amp reading. Okay, and move this over into come on. Okay, it's in there. Let's see. if we can get a reading. Okay, I had to take it off the stand, and it's getting a little dark. So the circuit is working. It dropped by 1 because we're using a diode. I think that diode's way too big for this low voltage. So, but that's not the point. The point is that we wanted to test if it was going to drop down. So that's what we had. We had 3. Now we have 2 using that big old diode. But if we turn that off and go back over to voltage, let's see. Okay, and that's what this one was putting out. I think that solar panel was a little damaged, but it's giving 17. Normally it gives 18, but we can see that it didn't drop back down. Now, if we didn't use this, okay, what we did was just put the lead over the positive, and you see that it dropped back down. Let's see if we can get a little light. That's what happens when you try to mix solar panels. Okay, see, that's the positive lead. Remember, the negative lead is just both going together. Let's see if we can get that in focus. So, but the positive leads has to be split with a diode, and depending on what size diode is what the results are going to be. But it will drop down, and this is what people talk about when they mix solar panels. Okay, so let's put that lead back. Okay, we put that lead back, and we're back again. Put the lead back, and we have 17. Okay, so again, we're going to make that circuit again, but we're going to make this diode much smaller. But you can see the diagram of that. So now let's go to the actual diagram. Put all this away. So let's go over this circuit, but first let's hear from the AI so people can look at the diagram I wrote. And here is what AI said about it. Let's see here.
It sounds like you're describing a setup where you're using diodes to prevent backflow of current from each solar panel and combining their outputs. Let's break down the configuration based on your description. Setup description. 1. Panel A DIY solar panel with 3A output. Positive lead is connected through a diode to prevent backflow. Negative lead is connected directly to the output. 2. Panel B, main solar panel with 18 volts output. Positive lead also connected through a diode to prevent backflow. Negative lead is connected directly to the output. Key points. Diode usage. You've correctly placed diodes on the positive leads of both panels to ensure that current flows only in one direction, outwards towards your load or battery bank. Combined output. By connecting the positive outputs of both panels together and the negative outputs together, you create a parallel connection. This allows the voltage to stabilize around the higher voltage panel, 18 volts from panel B, while the current will depend on the combined capacity, but limited by the lower current panel, 3/3/8 from panel A. Will it work? Yes. This, this setup should work effectively to combine the outputs of both solar panels without allowing backflow of current between them. Here's what you can expect. Voltage output, approximately 18 volts from panel B. Current output, up to 3A from panel A, assuming this is the limiting factor. Power output, 18 volts 3A equals 54 watts. And circuit board considerations. Ensure that the diodes used have a sufficient current rating to handle the combined output current. Check the wiring and connections carefully to avoid any short circuits or unintended paths for current flow. Consider using heat sinks or adequate cooling for diodes if they are expected to dissipate significant power. If you follow these guidelines and ensure proper assembly, your circuit board setup should effectively harness the combined power of both solar panels while maintaining the desired electrical characteristics. Let's break down the power consumption of your devices and compare it with the 54 watts output from your combined solar panels. 1. Power consumption. Device using 12 volt 2A, power equals voltage. Current equals 12 volts 2A equals 24 watts. Device using 5 volts 1A, power equals voltage, current 5 volts 1A equals 5 watt. Total power consumption equals 24 watts plus 5 watts, equals 29 watt. 2. Solar panel output. Combined output equals 54 watts. That comparison, power consumption devices, 29 watts. Solar panel output, 54 watts. The combined output of your solar panels, 54 watts, is greater than the total power consumption of your devices, 29 watts. This means that your solar panels are capable of providing enough power to run both devices simultaneously, with some additional power available for charging or storing energy. Conclusion. Yes, the 54 watt output from your solar panels has more power than what your devices are consuming, 29 watts. This surplus power can be utilized for charging batteries, operating additional devices, or stored for later use.
Okay.
It's important to ensure that your system is properly configured to handle the voltage and current requirements of both the solar panels and your devices to
Okay. That part right here, as you can see, I want to get that in focus, is that when I plug this in, you're plugging in 29 watts. That means that big cell, which is that big green one right there, uses a plug that is 12 volts 2 amps. And the little one plugs in the USB that uses 5 volts and 1 amp. Adding them both together, you get 29 watts of power being used between the two. Now, if I plug that into my equal flow, 29 watts is what it's going to use, because the solar cells produce this 54 watts. Then we can actually charge that equal flow, even though it would be small. But this is for demonstration purposes. We will up that later on. And this circuit that we're showing right here is going to get beefed up. This is just a simple circuit, because I told you I was going to answer your questions about mismatched solar panels. Now, you've heard from AI, you've seen it, you've seen the circuit, and we already knew that this simple circuit right here, this diode, would work. All you had to do is make a panel, which we did. We made a panel that gives you the amps. And everybody asked me, why are you making that panel that just makes amps? You put everything in parallel, okay? We measured, and let me see if I can get these pictures up here. We measured one single cell, which is giving me, out of 400 milliamps, it was giving me 70 milliamps from one. Then we hooked up, I think, close to 100. And then we got 3 out of that. And that 3, we now wanted that full 3 going through this circuit with the 18 volts, so it won't be pulled down with the voltage on this one here, A, which was 0.5 volts. We had the high milliamps, and then it had the low voltage. This one right here had low milliamps, very, very low. It was close to 0, like 87 milliamps, but it had 18 volts. Both of them use LED lights. So we wanted to mix this panel with this panel, and this is the circuit that does that. And when you get out, you get 18 volts from this panel, and you get the amps from this panel out here. Okay, so that's the circuit, and you got the explanation. Thank you.